Some math here, we push that rock. Let's talk about a fairly simple quadratic equation that's not factorable. We'll use the quadratic formula to solve it. And we're going to talk about some implications of that quadratic formula graphically. Okay, here we go. So, a quadratic equation is one that you can set. A quadratic equation, a simple quadratic equation is one that you can set equal to 0 and O and be in this form: ax squared plus bx plus c equals 0. And then we have this famous formula that finds the solutions to an equation of that. Let's blow this up so we can see it a little better. So an equation in this form, if you can get it to look like this equation will solve it. I mean, this formula right here will solve it. So the formula says that x is equal to the opposite of the linear coefficient plus or minus the square root of the binomial expression, that is the linear coefficient squared, minus 4 times the product of the leading coefficient and the constant, all divided by 2a. Let's use that formula to solve this equation here. So we're gonna need, well, I guess we wanna see the formula while we plug in. Okay, there we go. All right, we're gonna need to identify A, B, and C. So A is the leading coefficient, which is the number in front, 1. B is a -1. And C is the constant, 3. So I'm gonna plug into the formula. Now, I'll use some colors here. Notice that we have a couple of places to put B, so we're going to do that. We have a couple of places to put A, substitute A into the formula, so we'll do that. And then we have one place to substitute in C into the formula. So the formula says that you will have x equals the opposite of B, so negative of B. Remember, B is this yellow term right here, plus or minus the square root of the b squared. So again, I'm substituting in for the yellow. Okay, then we have minus 4 times a times c, and it's all over 2 times a. Now a I highlighted in purple, so I'll get my purple out and highlight A. A is going to go there and there, and then B, C is going to go here. Well, okay, so what was B? B was a -1. What was A? A was 1. And C was 3. So I just substituted in appropriately. Notice, can y'all see everything? Here we go, okay. Hope y'all can see that. So where there was a B, I put B. A, I put our A value, which was 1. And where there was a C, I put our C value, which was 3. And everywhere I substitute, I carefully use parentheses just to make sure I don't make any sign errors. And now I'm just going to follow the rule of order of operations. So the opposite of a -1 is a +1. We still have our plus or minus sign. Here is a -1 squared. That's a -1 times a -1, so that's a +1. Now, before I subtract, I have to multiply all this. Well, I have 4 times 1 times 3, so that's 12. And then I have 2 in the bottom. Okay, so we're going to get 1 plus or minus the square root of -11 over 2. Now, this plus or minus means you have 2 solutions. You have the solution where it's 1 plus the square root of -11 over 2, and you have the solution where it's 1 minus the square root of -11 over 2. However, the square root of a -11 is a problem because there is no real number that you multiply by itself. That's what square root means. Find the number that you multiply yourself to get the radicand. But there is no number that you multiply by itself and get a negative. So this is not a real solution. And that means graphically, an implication of this graphically is that you're not going to have any x-intercepts. So when you graph this particular, the parabola that gave you this equation, maybe your equation started off like x² minus x plus 3, and you set it equal to 0 to find the x-intercepts. and then you said, oh, it doesn't factor. I'll try a quadratic formula to find the x-intercepts. But then you got a negative under the radical. That means there's not going to be any real solutions. So if there's no real solutions, then there are no x-intercepts. And so you're not going to be able to just count on getting the x-intercepts to help you graph it. You're going to have to find some other points. But this still helped. How did it help? Notice that this can be written as 1/2. Let's look at this one here. It's 1 over 2. I don't know why I made that a plus. Let me fix that. Okay. It's 1 over 2 plus or minus this weird expression that's not real. But this is telling us that 1/2 is where the asymptote is, because you're at 1/2, there's a solution to the right this far, if that was a distance, and there's a solution to the left this far from 1/2. So this part of the solution, this 1/2 right here, let's highlight that. This is telling us where the axis of symmetry is. So if I wanted to graph the parabola, I know the axis of symmetry is at this 1/2. Now, if you just look at the formula, you can tell that right away. The formula, if I can rewrite this formula right here in this manner, I could say, hey, this is negative b over 2a. Oops, I don't know what I'm doing there, over 2a, plus or minus this radical expression over 2a, because this is all of this over 2a, so both terms in the numerator are over the denominator. So that means the vertex is always going to have this x value here. That's going to be the x value of the vertex every time, because your solutions are going to be this plus something and this minus something, so this is the point that is right in the middle of the two solutions. So therefore that's your x value of your vertex, and so you always know your x where your axis of symmetry is by just looking at negative b over 2a. So we didn't find any solutions to this, but we can graph this now. Let's draw a Cartesian plane. We know there's a y-intercept of 3. We know that at 1/2, it was at 1/2, was our negative b over 2a. If I took the negative of b, which is positive 1, and put it over 2a, I get 1/2. So at 1/2, I'll make this 1, so this is 1/2. I have an axis of symmetry. That means if there's a point 1/2 to the left of it at 3, then there's a point 1/2 to the right of it at 3. And if I put 1/2 into this equation for the x's, I'll get the y point that is on the axis of symmetry that we call the vertex. So if I put 1/2 here, I get 1/4. Because 1/2 to 1/2 is a 1/4. Minus 1/2 is a negative 1/4, right? You got a quarter minus 50 cents, you're at a negative quarter, plus 3. Well, negative quarter plus 3 is 2 3/4. So the vertex is at 2 3/4 right here. So our parabola is up here above the x-axis. It never touches the x-axis, and that's why we got not real solutions when we tried the quadratic formula. But there's our graph right there. So there's some implications of the quadratic formula and how to use the quadratic formula to solve for the x-intercepts of a quadratic function, or to solve a quadratic equation that you have set equal to 0. Math made simple, Simpson Math.